Alright, welcome aboard, guys. Today I'm going to be tackling the day 8 Shellcodes of the World Unite from this Advent of Cyber 2024 from TryHackMe. Alright, so let's get to it, right? Glitch the hacker, clever yet distrusted, wrote a script with skills finely adjusted, shellcode magic to his home he would send, where secrets of wearables he carefully penned. Okay, Glitch, a skilled but mistrusted hacker, was prepping for a tech conference. He was eager to share his shellcode script that remotely accessed his home system. As he worked, he noticed Mayor Malware's henchmen lurking nearby. They're wasting their time. I don't have anything they want, Glitch chuckled. He didn't realize that hidden in his home system was something they desperately sought. A research paper he wrote on Wareville's defenses, a treasure Mayor Malware was eager to obtain. The learning objectives. Grasp the fundamentals of writing shellcode, generate shellcode for reverse shells, execute shellcode with PowerShell. Connecting to the machine before moving forward, review the questions in the connection card shown below. Okay. Am I given credentials? Yes, I am. Okay, let's start this machine already. And then, okay. Aside from the end, you must also start the attack box for this task. Click on the Start Attack Box button located above this page. Essential terminologies. A reverse shell to a system so tight he planned to showcase at the tech conference night. Eager to share how his shellcode could impress, he aimed to enlighten, to teach, and progress. Okay. Before we start, review some important concepts to help you better understand the upcoming content. Shellcode is an advanced topic, but knowing these foundational ideas will make the rest of the material more accessible and engaging. So, shellcode, a piece of code usually used by malicious actors during exploits like buffer overflow attacks to inject commands into a vulnerable system, often leading to executing arbitrary commands or giving attackers control over a compromised machine. Shellcode is typically written in assembly language and delivered through various techniques, depending on the exploited vulnerability. PowerShell, right? A PowerShell scripting language and command line shell built into Windows for task automation and configuration management. It allows users to interact with system components and it's widely used by administrators for legitimate purposes. However, attackers often use PowerShell as a post-exploitation tool because of its deep access to system resources and ability to run scripts directly in memory, avoiding disk-based detection mechanisms. Then comes Windows Defender, a built-in security feature that detects and prevents malicious scripts, including PowerShell-based attacks, by scanning code at runtime. Common bypass methods for evading Defender include obfuscating scripts to disguise malicious content, making it harder for the software to recognize known patterns. Another technique is a reflective injection, where malicious code is loaded directly into memory, avoiding detection by signature-based defenses. We'll cover the latter one in this task. Okay. Then comes Windows API. The Windows Application Programming Interface allows programs to interact with the underlying operating system, giving them access to essential system-level functions such as memory management, file operations, and networking. It serves as a bridge between the application and the operating system, enabling efficient resource handling. The Windows API is crucial because many exploitation techniques and malware rely on it to manipulate processes, allocate memory, and execute shellcodes. Common Windows API functions frequently used by malicious actors include virtual alloc, create thread, wait for a single object, which we will also use in this task for exploitation. Accessing Windows API through PowerShell reflection. So Windows API by a PowerShell reflection is an advanced technique that enables dynamic interaction with the Windows API from PowerShell. Instead of relying on precompiled binaries, PowerShell reflection allows attackers to call Windows API functions directly at runtime. This will enable them to manipulate low-level system processes, making it a primary tool for bypassing security mechanisms, interacting with the operating system, and executing code stealthily. Then comes reverse shell, right? A type of connection in which the target, the machine you're trying to hack, initiates a connection back to your attacking machine. In this case, your machine will be the attack box. Yeah, sure. Sure it will be. So the attacker, it has a particular IP, and then reverse shell exploitation, right? And then the victim provides us with the reverse TCP connection to this particular IP address, and then the port 4444. Okay. Is the one that's going to be used by the attacker, and then we get like access to execute commands on this particular victim machine, right? So generating shellcode. But Mayor Malware's minions, Sneaky and Sly, found the script and gave it a try. They tampered the code, changed port and IP, twisted its word with a sinister glee. Okay, let's learn how to generate a shellcode to see what it looks like. To do this, we'll use a tool called MSF Venom to get a reverse shell. In the attack box, open the terminal and enter the command MSF Venom. I guess I could also use my own, right? VPN. Like my own attack box. I just have to connect to the VPN from TryHackMe. And then what if I just execute this command? So what are we doing? P Windows, yeah, lhost attack box IP. Oh, okay. So what is my IP? 10.661.124. Oh, wait up. Attack box IP. It means this IP, right? So, okay, let's read through this, okay? Before moving forward, do I need to start the attack box today? VM in split screen, yes. Am I giving credentials to connect directly to the VM via RDP, VNC, or SSH? Yes, I am giving connect. Okay, so I guess I can just connect, right? SSH glitch at 10.10.136.190, and then it should prompt me to. Is that correct syntax? I don't think so. What? I feel like I'm doing something wrong. No, no. Yeah. Stage syntax. User at host, right? Yeah, that's it. That's correct. So am I connected? Okay, so am I able to just interact with that particular machine, 136.190? Yeah. Yeah, I am. So, oh, you can connect to the VM by a remote desktop. Oh, it's because it's a Windows machine, right? Um, so Remina, yeah, sure. So let's copy the password. So we already know the username, which is glitch. Password copied, and then also the IP. Exit split screen view. Okay, yeah. Server, yeah. This connect. What up now? Yes. Uh, 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 Okay. We are connected to the Windows machine. That's good. That's what we wanted. Oh, let's put this on split screen. Okay. So, you asked me something. So, generating shellcode, yeah, that's what we're doing. Let's learn how to generate a shellcode to see what it looks like. To do this, we will use a tool called MSF Venom, okay, to get a reverse shell. In the attack box, which means in this particular, open the terminal and enter the command MSF Venom. Wait. No, this is not the attack box. I'm getting confused right here. The attack box means the machine that they provide us with that we could use to attack this or compromise this Windows machine, right? Which in this case, I'm just using my own. So in the attack box, open the terminal and enter the command this PowerShell that will attack box IP. So that would mean basically my own IP, right? Which is 10.661.124. 10.661.124. Is that it? 10.661.124. Yeah, 10.661.124. L port. Okay, minus F PowerShell. Sure. So what up now? I'll host. Okay. That will generate the shellcode. The output will look like the following. You are required to replace the attack box IP with the IP of the attack box. Okay, no encoded. Yeah, it did generate something. Uh-huh. No platform was selected. Choosing MSF module. Yeah, no arch selected. Selecting Arch64, just the same, right? So the above command generates a piece of shellcode using MS Advent. Here's what each part means. -p Windows x64 shell reverse TCP. The -p flag tells MS Advent what type of payload to create. Windows 64 shell reverse TCP specifies that we want a reverse shell for a Windows machine. Oh yeah, that's true. Okay, let's keep going. lhost equal attack box. This is the IP address of the attack box. It tells the reverse shell where to connect back to. Okay, which is our own machine, right? My own machine, my own Kali box. So L port, yeah, it's just the old port number. This is the port number on your machine that will listen for the reverse shell connection. When the target connects back to you, it will use this port 1111. In this example, you can choose any available port, but it needs to match with what your listener is set to. And then -f PowerShell, this specifies the format for the output. In this case, we want the payload to be in PowerShell format so it can be executed as a script on a Windows machine. Okay, so what is the actual shellcode? Right, the actual shellcode in the output above is the hex code byte array, which start with these particular items or strings or hex code, right, and so on. The hexadecimal numbers represent the instructions set on the target machine. Computers understand binary ones and zeros, but hex numbers are just a more human readable version. So instead of seeing long strings of ones and zeros, you see something like this instead. We can execute this shellcode by loading it into memory and then creating a thread for its execution. In this case, we'll use PowerShell to call a few Windows APIs via C# code. Below is a simple PowerShell script that will execute our shellcode. Okay, so a few, that's a lot of code, but don't stress, we'll break down what it does step by step. Okay, so you allocate some memory using system runtime, okay, public class, log, kernel 32, public stern, okay, add type, wait for, add type, wait for, all right, and then add type byte shellcode placeholder. Okay, if you're new to cybersecurity, memorizing these functions is unnecessary. Most penetration testers use pre-made or automated tools to run shellcode, so you don't have to know every technical detail to complete the job, no need to worry. Explanation of the code. So the script starts by defining a few C# classes, right? You can see them here, public class, right? They're defining some C# classes. Yeah, and then where were we? Yeah, these classes use the DLL import attribute to load specific functions from the kernel 32 DLL, which is part of the Windows API. So virtual alloc, these functions allocates memory in the process address space. It's commonly used in scenarios like this to prepare memory for storing and executing shellcode. And then create thread. This function creates a new thread in the process. The thread will execute the shellcode that has been loaded into memory, and then wait for a single object. This function pauses execution until a specific thread finishes its task. In this case, it ensures that the shellcode has completed execution. So these classes are then added to PowerShell using the add type command, allowing PowerShell to use these functions. Yeah. Add type. Yeah, sure. Okay. Storing the shellcode in the byte array. Next script stores the shellcode in the buff variable, a byte array. In the example above, shellcode placeholder is just there to show where you would insert the actual shellcode, earlier generated through MS Advent. Usually you replace it with the real shellcode, represent the series of hexadecimal values. These hex values are the instructions that will be executed when the shellcode runs. Allocating memory for the shellcode. So the virtual alloc function then allocates a block of memory where the shellcode will be stored. The script uses the following argument. 0 for the memory address means that Windows will decide where to allocate the memory. Then $size for the size of the memory block, which is determined by the length of the shellcode. And then 0 times 3000 for the allocation type, which tells Windows to reverse and commit the memory. And then 0x40 for memory protection. The memory is readable and executable, necessary for executing shellcode. After memory is allocated, the marshal.copy function copies the shellcode from the above array into the allocated memory address, preparing it for execution. Where is that? Where is the particular marshal copy? I guess it's over here, marshal, yeah. Okay, function copies the shellcode from the buffer array into the allocated memory address, which is $ADDR, preparing it for execution. Then comes executing the shellcode and waiting for completion. Once the shellcode is stored in memory, the script calls the create thread function to execute the shellcode by creating a new thread. This thread is instructed to store execution from memory address where the shellcode is located at address. The script then uses the wait for single object function, ensuring it waits for the shellcode execution to finish before continuing. This makes sure that the shellcode runs completely before the script ends its time execution. Okay, so we were time for some action, right? We're trying to execute the shellcode. I already set up the listener on my own DAC box, so it's listening here. So we just need to trigger this particular shellcode, right? So it's listening on the attack box terminal. Begin by navigating to the desktop, right click on desktop, select create document, then choose empty file. So let's go here. Then I guess I have to create something in, of course, not in the desktop, right? TryHackMe, and then Advent of Cyber. Yeah, and then which day is it? Is this day 7? Not sure. 8. Okay, so let's go through that. So yeah, 8. So make here day 8, right? And then day 8 is where we will have this particular shellcode. So they ask us to then choose empty file, open this new file and paste the previously provided PowerShell script code into it, which is this particular code, right? Okay, so let's copy all this and then paste it. So I'm gonna just create, what name should I give it? Like any name should do. Where are we? Mrs. Venom, yeah, sure, here. And then once you've added and replaced it, empty file, open this new file and paste the previously provided PowerShell script and code into it. Look for the part labeled this and replace it with the shellcode we previously created with MS Venom. Right, so this is just PowerShell script, I guess. Script, and then we can paste it. And paste all that, and then we can. Then what are you asking here? Shellcode placeholder. Oh yeah. So in the shellcode placeholder, you're asking me to, where did I generate that? Oh, it was here. So I guess I can copy all this. From where? But wait up. From where do I copy the? From where does the shellcode start? I'm sorry, I haven't done this in a while. So I'm just trying to learn here again. Buff, right? Okay, wait up. Is it from the buff, I guess? Yeah, right? Should be from here, right? Yeah. So let's, okay. Let's do this. This is how we do it. This is how we do it. Yeah. It's not take too much time scoping this. Okay, so we got it. So now we want to edit this again. And then here, where was the shellcode placeholder? Here, right? Oh, we already had the buff here. So I guess we just need to provide it with this. I already replaced the whole thing. Shouldn't be a problem. So I'll save it and I exit it. And then what up? What do you want me to do now? So we're already listening. I created the empty file, open this file and paste the previously provided PowerShell script code into it. Look for the part labeled shellcode placeholder and replace it with the shellcode we previously created with MS Venom, already done. Once you've added the shellcode, navigate to the attached VM, open PowerShell. The attached VM means this particular Windows box, right? Navigate to this, open PowerShell by clicking the PowerShell icon on the taskbar and paste parts of the code from the document you recently created to the Windows PowerShell window. For example, the first part to copy and paste is the block below. Okay. Runtime. Sure. Then paste this line below. Replacing the placeholder with the shellcode generated by MS Venom and press enter. Okay, what I'm gonna do is just copy all this. So for example, the first part to copy and paste is the block below. So you're asking me to just open PowerShell and just paste that, right? That's what you're asking me. So should be safe to do this. Control C, then Control V. Come on. It's not copy and pasting. Why? What if I just, I don't know, create a new text document? Just a new text document should do. I just want to test out if the paste functionality is working, at least in the notepad, or otherwise it should not be receiving. So it's not triggering any copy. Oh yeah, here it is. Control C. Now what? Can I please paste it here? And then this. If I just Control Shift doesn't seem to work. Control V also doesn't work. So how am I gonna then paste the line below, replacing the placeholder? So once you've added the shellcode, you want me to open PowerShell, like click the PowerShell icon on the taskbar and paste parts of the code from the document you recently created in the to the Windows PowerShell window. For example, the first part to copy and paste is the block below. That's what I'm trying to do, but it's not letting me. So what should I try? Maybe right clicking on it. Maybe if I right click here, edit, paste. It's not letting me. Maybe I have to open it with administrator permissions. Oh no. Although I do have the password, right? Should be this one. I don't know if Glitch has, if a Glitch and the administrator use the same password. I guess we're gonna find out. Password. Nope. So I can't open it as an administrator. They're asking me to run that particular thingy. I can't seem to copy and paste. So I don't know. Okay. Yeah. Maybe if I just do it like public class, then add type, right? So let's try the first thing first. The first block. What now? Okay, now it seems like it worked. So now if I just put enter, then what? It stopped working. Okay. So I guess now we can just add this particular thingy. Wait. I guess we can execute all this. Then we can execute all this. Wait for. Why can't I just copy and paste the whole thing? Are you serious? Right? Come on. See? When I try copy and paste the whole thing, it doesn't work. So let's do it by parts, I guess. Let's try this. Enter. Now let's try this. Enter. What happened? Okay. Wait for, yeah, sure. The thingy, I'll type, yeah. And then, so we already added the wait for. No, this is the last part. Okay, this, and then this goes here. Now, then paste the line below, replacing the placeholder with the shellcode generated. Okay, so now we have to paste that line, which we have here, right? Being PowerShell. Basically, it's this line. So we can just copy, paste, right? Just the whole thing. And continue copying and pasting lines from the code below. Remember to copy one line at a time, paste it, and press enter. Okay. So they're asking me to copy one line at a time. So we can do that. Should not copy. Copy. Okay, now it worked. Now this as well. Or shall copy this as well. Okay, what now? System runtime. Yeah. Now this last one. Copy. Paste. Uh-oh. Copy. Paste. Come on. No. Doesn't seem to be working. Maybe one line at a time. Here. Yeah, sure. Now this. Yeah. Okay. Now, note, if your PowerShell terminal unexpectedly closes, it means your NC listener was not reachable, possibly because it was not running or was listening on the wrong port or IP. But let's check it out. Oh yeah, we got shell access. So if you've done it properly, the PowerShell terminal DVM will look like the screenshot. Type wait for, yeah. Wait for, yeah. Once you execute the final line in the PowerShell terminal and press enter, you will get a reverse shell in the attack box, which is what we did, right? We just got access for my glitch, and I'm inside a Windows machine. The final PowerShell terminal and press enter, you will get a reverse shell in the attack box, giving you complete access to the computer, even if the Windows Defender is enabled. Now you can issue any command, like issuing dir, which will list all the directories. Yeah, it does. So what do you want me to do now? Regaining access. So now Glitch must act, no time to delay. To fix the shellcode and keep foes at bay, he tweaks and he goes to set the wrongs right, protecting his secrets with all of his might. So let's dive into the story and troubleshoot the issue in this part of the task. Glitch has realized he's no longer receiving incoming connections from his home base. Mayor Malware's minion team seems to have tampered with the shellcode and updated both the IP and port, preventing Glitch from connecting. The correct IP address for Glitch is the attack box IP, and the successful connection port should be 4444. Can you help Glitch identify and update the shellcode with the correct IP and port to restore the connection and reclaim control? So what is the flag value once Glitch gets reversal on the digital vault using port? Note, the flag may take around a minute to appear in the Glitch desktop. Do I really there's no flag here. Directory, you can be the contents of a flag by using the command type flag.txt, which I don't see there. I guess I do have to just edit this just to connect using a different port. Okay, so let's dive into the story and troubleshoot the issue in this part of the task. So Glitch has realized he's no longer receiving incoming connections from his home base. Okay, so Mayor Malware's minion team seems to have tampered with the shellcode and updated both the IP and port, preventing Glitch from connecting. The correct IP address for Glitch is the attack box IP, and the successful connection port should be 444. Okay, so let's exit this, right? Now let's set this up in 444. And then what we have to do is I guess we have to generate another one, right? Because we used a particular IP, which is this one, but the L port needs to change. So we have to use this again. So I guess I can just go back and use Venom. Yeah, here. And then the L port needs to be 4444, right? That's what they're asking me to do. And the successful connection port should be 4444. Okay, so can you help Glitch identify and update the shellcode with the correct IP and port to restore the connection and reclaim control? Identify and update the shellcode with the correct IP. Yeah, so we want to generate a new shellcode basically, right? With this particular correct IP, which is gonna be this. So now, what now? Well, am I gonna have to execute all these PowerShell line by line as before? Maybe yeah, maybe no. Let's find out. We're here in Glitch. So once you've added, yeah, blah 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 blah. Sure. Okay, so let's try it. Okay. So yeah, enter. Now the next one is this particular thingy. Wait for it. No. Paste, enter. Now the next one is this. Then copy and then paste. Come on, don't fail me now. Come on, you were doing just great. What happened to you? Okay, this doesn't seem to want to copy. Let's do it again. What now? Not yet. I guess we can try this. Yeah. And then public class. And then what up? Come on. Uh-huh. Yeah, okay, finally. Okay, then paste the line below, replacing the placeholder with the shellcode generated by MSF Venom, right? Which we have here. So jank. And now let's go to our PowerShell, which is here. PowerShell, yeah, we need to execute it from the byte. Yeah. Continue copying and pasting the lines from the code below. Remember, copy one line at a time. Yeah, sure, we can do that. Yeah. So one line at a time. Yeah, this one thing. Are we listening though? I think we are, yeah, we are. So now, first line executed. Let's go to the second one. Yeah, executed as well. Let's go to the third one. Executed as well. And then let's go through the last one. Execute, and this should give us the shellcode thingy, right? The response, yeah, it does. So there, desktop, there, there. Oh, we got a flag. So type flag .txt, and now we get the flag, which is the one that they were asking us here, right? So user bleeds desktop, you can be the content of the flag by using the command type. Yeah, we already used that. So that's it. That was fairly easy, right? So that's all for this particular day of Advent of Cyber, guys. I'll see you on the next one. Thanks for sticking up with me. Yeah, I'll see you.